In this lesson, we're going to look at logistic regression. Let's start with the logistic regression model, which is that the probability of getting a positive outcome is 1 over 1 plus e to a negative alpha. Okay, so the question is, what is alpha? Alpha is a linear regression equation, or a linear equation, and it starts with the y-intercept, which is beta naught, plus our first coefficient, or beta sub 1, that is the first coefficient for our independent variable, x sub 1. And if we have an additional independent variable, we'll have another coefficient, beta sub 2, times x sub 2. And we can continue to add terms as we have more independent variables. Now, this equation gives us the probability, P, that we have a positive output. Now, the probability of a negative output is Q, which is basically equal to 1 minus P. And that is to say that our probability goes from 0 to 1. So whatever P is, if we take 1 and subtract P, we will get the remaining probability to equal 100%, and that gives us the probability Q that our outcome is not true. So we could say that P is the probability, capital P, that our dependent variable, y, is number 1, which means it's positive, and Q is the probability that y is equal to 0, because it's not true. Squeeze that in. So as it turns out, the linear equation alpha is equal to the natural log of the probability P that our output, or y equals 1, that is a true outcome, over the probability that we have a false outcome. And we can write this as also the natural log of little p over 1 minus p. And this is called the logit function. This is the logit of P, the probability of a true outcome. So our logistic regression equation tells us that the probability that an outcome will be positive or true is 1 over 1 plus e to the negative beta naught plus beta sub 1 x sub 1 plus, and we're going to keep on going until we've created a term or added a term for each of our independent variables. Let's take a look at what this looks like when we graph it. So here we're going to take our equation for the probability of a true outcome, which is 1 over 1 plus e to the negative alpha, where alpha is our logit function. And if we graph this, our x-axis is our alpha value, and our y-axis is our probability. And our probability is going to go from 0 to 1. And what this is that if we have a probability of 0, that's a 0% probability that we will have a true outcome. And a probability of 1 means that there is a 100% probability that we will have a true outcome. Now let's look at our x-axis and put some tick marks here. And these are our positive alpha values as we move to the right. And here, to the left of 0, we have our negative alpha values as we move to the left. So let's look at what our function looks like as we go to the right and to the left. And as we go to the right from 0 with our alpha values, our probability gets closer to 1, approaching 1, never actually reaching 1. And as we go from 0 to the left, our p-value gets closer to 0 probability, never reaching a probability of 0. So when alpha is 0, we have a probability of 50% that our output or outcome will be true. And as it approaches positive infinity, and it gets more and more, I should say, becomes larger and stays positive, we are approaching a probability of 100%. As our alpha approaches a negative infinity, our probability approaches 0. Now, if we graph the logit of p with respect to one of the independent variables, and we'll call that x, and we call this x value our predictor, and in this case I'm graphing it with respect to one predictor or one independent variable, and the y-axis represents the logit of p, or the probability that y equals 1. The result is going to be a straight line. And that straight line is beta naught plus beta sub 1 times x, where this x is our predictor.